Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the fifth question from the May-June 2024 Physical Science Paper 1. Please do expect a total number of 10 videos since this question paper has 10 questions. Né? And all of these questions guys will have their own video. And please note that guys, it's very important for you to know how to tackle exam questions. I strongly believe it will give you an edge whenever you write your final exam. So please do share the video to your peers so that they may have the same edge as you. Né? And please guys, do help us grow the channel by just subscribing, please. Okay. A crate of mass 18 kilograms initially at rest slides down a frictionless slope from point A to point B. And then the crate then moves along a rough horizontal surface from point B towards point C. Point A is 3 meters above the horizontal surface. See the diagram below. Okay, point A to B is a smooth surface, né? But point B to C is a rough horizontal surface. What can I conclude over there? Since path A to B does not have frictional force and there's no constant applied force on the block, that means we do not have non-conservative forces. And in the absence of non-conservative forces, mechanical energy is conserved because we have a closed system. Are we together? But for path B to C, mechanical energy is not conserved because we have external forces such as friction. Are we together? Okay, first question, they want us to state the principle of mechanical energy in words. It simply states that in a closed system, mechanical energy is conserved. Are we together? Or you can say, in an isolated system, mechanical energy is conserved. But what is mechanical energy, guys? Né? Mechanical energy is just the sum of both kinetic energy and potential energy. Are you together? Okay. 5.2, we are being asked to use energy principles only to calculate the speed of the crate at point B. I can find the speed of the crate at point B. Why? Because I know that from A to B, mechanical energy is conserved. So mechanical energy at position A is equal to the mechanical energy at position B. Why? Because A to B does not have non-conservative forces. So in the absence of non-conservative forces, guys, please always know that mechanical energy is conserved. Okay, so I can simply say that the kinetic energy at position A, that's 1 over 2 mv squared at A, plus the potential energy at position A must be equal to the kinetic energy at position B plus the potential energy at position B. Now let's substitute. Since guys the crate, is it the crate or a box? Or since the crate is released from rest, it simply means that its initial velocity is 0. The velocity of the crate at position A will be equal to 0, and hence the kinetic energy is also equal to 0 joules. So the kinetic energy is 0 because the velocity is 0. Plus mgh, the mass of the crate is just 18 kilograms. 18 multiplied by 9.8 multiplied by the height above the ground, which is equal to 3. This is equal to 1 over 2 multiplied by 18 kilograms multiplied by the velocity at position B. Plus, whenever the crate is at position B, the crate is 0 meters above the ground. If the height above the ground is 0, it simply means that the potential energy is also equal to 0 joules. So I simply have 0 over there. Then all I have to do is to just calculate. I have 18 on the left hand side multiplied by 9.8 multiplied by 3. this will simply give me 529.2. On the other side, 1 over 2 multiplied by 18, this will simply give me 9. This looks like I said 9.8. That's 18, né? I'll simply get 9 multiplied by v squared. If ever I divide both sides by 9, what's that? Yeah, I'll simply get 58.8 is equal to velocity at b squared. Therefore, the velocity at b, just find the square root on both sides. This will simply give me 7.668. That's 7.67 meters per second. So the velocity of the crate at position B, that's 7.67 meters per second. Velocity, or the speed actually, that's 7.67 meters per second. A constant frictional force of 40.6 newtons acts on the crate as it moves from position B towards position C. The crate comes to rest at position C. I now know that the velocity over there is 0 meters per second because this thing will come to a stop. Okay. First question, I'm being asked to state the work energy theorem in words. It simply states that the net work done on an object is equals to the object's change in kinetic energy. The net work done on an object is equal to the object's change in kinetic energy. Okay, we are supposed to use energy principles only to calculate the distance that the crate traveled from point B to point C. Okay, over there I can simply use the work energy theorem or use the work done by non-conservative forces, since I do have a non-conservative force over there. Ne? Since they did not force me to use work energy theorem, I can simply go for work done by non-conservative forces. The work done by non-conservative forces is equal to the change in kinetic energy plus the change in potential energy. Né? There's only one non-conservative force over there, and that non-conservative force is just work done by friction, by kinetic friction. Né? And then change in kinetic energy is just half mv squared final, or rather at position C, minus half mv squared at position B, plus the change in potential 0. The change in potential energy rather is equal to 0. Ne? The change in potential energy is equal to 0. Why is that? Because the height of the crate does not change. The crate is still moving at the ground. So the height is still 0, whether at position B or position C. So the change in potential energy will also be equal to 0. Work done by friction. Remember that, guys, for me to find work done on an object, I just need to take the magnitude of the force multiplied by the displacement traveled and the cos of the angle between the force and the direction of motion. Ne? They want us to find the distance, so we are looking for delta x. So the magnitude of the force, that's 40.6. Let me confirm. Yeah, it was given as 40.6 newtons. I do not know delta x, but I know that the angle between frictional force and the direction of motion is always 180 degrees, because frictional force will forever oppose motion. Okay, that's 1 over 2 multiplied by 18. At position C, the crate will come to rest, so the kinetic energy, or rather the velocity at C, will be equal to 0, ne? Minus 1 over 2 multiplied by 18 multiplied by 7.67 squared. On the left hand side, I'll simply get negative 40.6 delta x. On the right hand side, I'll have 0 minus negative 1 over 2 multiplied by 18 multiplied by 7.67 squared. This will simply give me 529.46. Then I'll divide both sides by negative 40. Therefore, the displacement covered by the crate will simply be equal to 13.04 meters. Are you together? 529.46 divided by 40. That's 13.04 meters. So the distance covered by the crate is basically 13.04 meters. Okay, the height of the track is now lowered so that point A is at a vertical height of less than 3 meters. The same crate is again released from point A. How will the distance covered by the crate along the horizontal surface before it comes to rest compare to the distance calculated? I know that it will be smaller than, but why is that? Because guys, from A to B, whenever I decrease the height, that means I'm decreasing the mechanical energy. Are you together? I'm decreasing the mechanical energy as well. With a decrease in mechanical energy, it simply means that the crate will reach position B with a lower kinetic energy. Are you together? And obviously, if it reaches position B with a lower kinetic energy, that means the speed at position B is also small. Are you together? So since the kinetic energy over there is small, that means the momentum will, okay, let's forget about momentum. Ne? That means the speed over there is small as well. Ne? So with a lower velocity, the crate cannot cover this amount of distance, but it will cover a distance which is lower than 13.04 meters. Are you together? This thing, the distance will be smaller than, why? Because if ever we decrease the height above the ground, we are decreasing the mechanical energy of the object. When you decrease the mechanical energy, we also affect the kinetic energy at position B. Are you together? So after decreasing the whenever the kinetic energy is also decreased, that means the speed is decreased. And with a lower speed, if the crate has a lower speed over there, that means it will never cover a distance of 13.04 meters, but it will cover a distance which is smaller than 13.04 meters. That's how, guys, we're supposed to tackle the 5th question over there. So just stay tuned, guys, and wait for more videos. Thank you for your time.